As NAD-boosting supplements such as nicotinamide riboside, NR, and nicotinamide mononucleotide, NMN, have gained popularity in the fields of aging, metabolic health, and overall vitality, questions about their long-term safety have naturally arisen. Researchers have now accumulated a growing body of evidence from clinical trials, preclinical studies, and observational data, providing reassurance about their tolerability while highlighting considerations for optimal dosing, potential side effects, and areas that warrant ongoing monitoring. The emerging consensus is that, when used responsibly, NAD precursors are among the more promising and low-risk interventions for promoting cellular health and resilience over time. Clinical trials in healthy adults, older populations, and individuals with metabolic risk factors have consistently shown that NR and NMN are well tolerated at typical supplemental doses. Short-term studies lasting from several weeks to a few months have reported minimal adverse effects, generally limited to mild gastrointestinal discomfort, transient nausea, or occasional flushing, particularly with nicotinic acid rather than NR or NMN. Importantly, no serious adverse events have been consistently associated with these compounds, and markers of liver and kidney function have remained stable across multiple studies, even in older adults or those with pre-existing metabolic concerns. These findings suggest a robust safety profile for typical supplemental regimens and support continued investigation for long-term use. Dosing is an area of active research, with studies testing a range of amounts from modest daily intakes of a few hundred milligrams of NR or NMN to higher experimental doses designed to maximize NAD levels. Current evidence indicates that moderate doses are sufficient to elevate NAD systemically and confer measurable metabolic and cellular benefits without causing significant side effects. Higher doses have been explored safely in short-term studies, but long-term data remain limited, highlighting the importance of measured, evidence-based supplementation strategies. Researchers emphasize starting with moderate doses, monitoring individual responses, and integrating lifestyle factors such as diet and exercise, which naturally support NAD metabolism, to optimize safety and efficacy. Preclinical studies further reinforce the safety profile of NAD precursors. Animal models receiving long-term NR or NMN supplementation have not shown toxicity or organ damage, even when intake levels exceed those typically used in humans. In fact, these studies often report beneficial outcomes, including improved mitochondrial function, enhanced DNA repair, reduced inflammation, and better metabolic flexibility. While direct translation from animals to humans must be approached cautiously, these findings provide additional confidence that long-term NAD support is biologically compatible and may support multiple aspects of health simultaneously. Ongoing and planned long-term human trials are crucial to fully understanding the effects of sustained NAD supplementation over years or decades. Researchers are particularly interested in tracking outcomes such as cardiovascular health, cognitive function, metabolic resilience, and cancer incidence, alongside traditional safety markers like liver enzymes, kidney function, and blood pressure. These studies will also help clarify optimal dosing strategies across age groups, sex, and metabolic status, providing a more personalized approach to NAD supplementation that maximizes benefit while minimizing risk. Early indications suggest that long-term supplementation could become a safe and effective tool for maintaining energy production, mitochondrial function, and cellular repair well into older age. An additional consideration is the form of B3 used. NR and NMN are generally preferred for NAD restoration due to their direct conversion pathways and low incidence of flushing or gastrointestinal discomfort, which is more commonly associated with high-dose nicotinic acid. Niacin from dietary sources remains safe and supportive as a baseline strategy, complementing supplementation. By combining these approaches with a nutrient-dense diet, regular exercise, adequate sleep, and stress management, individuals can support NAD levels naturally while safely exploring the benefits of targeted supplementation. What makes the current safety outlook especially encouraging is the alignment of biological plausibility with empirical evidence. NAD is a naturally occurring molecule present in every human cell, and supplementation with its precursors primarily restores what is gradually lost with age, rather than introducing a foreign pharmacological agent. This intrinsic compatibility may explain why NR and NMN are well tolerated, even when taken over extended periods, and why they appear to synergize effectively with lifestyle interventions to enhance mitochondrial health, DNA repair, metabolic regulation, and overall cellular resilience. While no intervention is completely without risk, the available evidence positions NAD precursors as a uniquely promising category of supplements, combining safety, tolerability, and wide-ranging potential benefits. As research continues, the refinement of long-term dosing protocols, personalized approaches, and combination strategies with lifestyle and other therapeutics is likely to further enhance both efficacy and safety. For those seeking to maintain energy, metabolic balance, and cellular health into later life, NAD supplementation represents a scientifically grounded, well-tolerated, and increasingly validated option that holds considerable promise for supporting healthy aging and resilience over the long term.